Hello, everyone. Welcome to this webinar devoted to Kotlin features that describe what you might expect in Kotlin in the future. My name is Svetlana Isakova. I'm developer advocate in Kotlin, and today with us is Roman Elizarov. I think you know him, so no need to present Roman, the lead of Kotlin right now. Hi, Roma.
Nice to meet you. Hello, everybody.
So let's begin. Let's start. You've already, we think you've already seen our survey. So the idea of the survey is that you can share your opinion of what possible features in the language look the most important personally to you and your use cases. And we need this general picture in order to prioritize things for the future. Important note that it's not for Kotlin 1.6. Kotlin 1.6 is already planned, and Roma shared the nearest plan in terms of the language design for it at our 1.5 event. So now we are talking about the prioritization of the features that will be considered afterwards. And we need your opinion, which of the features you find the most important. So you already saw the features. If probably you already saw the survey. This is again, if you haven't voted, follow this link and you will come straight to the survey where you can choose 3 features that seem most important to you. And today during the webinar, we'll briefly highlight part of these features and also answer your questions. Please write your questions and comments in the chat. So if you have any questions, we have some questions pre-posted. We'll try to answer them. And also, if you have any questions right now, please write them directly in the chat, and Roma at the end of the talk will answer this. So good. Let's then begin with the features. Yes, and the format will be the following. I will highlight briefly the problem, and Roma will afterwards will describe possible different solutions and probably some complexity standing behind these features, or some more information about which one. And in the meantime, if you have questions about something that is currently described, we'll try to answer that straight away. So let's begin. And we begin with companion objects and static extensions. That's probably one of the features that is often named as one of the things people miss in Kotlin. And by the way, note, we have this highlighting with division of problem and solutions in the top right corner. So you can always see what currently is described. So the problem is that, say you want to define the static extension or define a member as a static extension for a class. But in Kotlin, you can do it only if the class defines a companion object. You can't provide the same functionality for a third-party library class. It just doesn't work if this class doesn't have a companion object. So it's the only way, and often it's inconvenient. A related problem to this area is that sometimes you would like to group static declarations together, but currently it's possible only with an object. So in order to do this, you need to define an object, and you can only provide this grouping in it, such grouping in it. So for instance, it works for library classes like objects like delegates, or if you define your own class, you have a similar problem. And it all comes with an additional overhead. So whenever you create an object or companion object, again, it's the only current way to declare static methods. And in comparison to Java static classes, it adds additional overhead to the Java bytecode. So we have these problems kind of grouped together, and there are possible solutions to it. So now, Roma, can you highlight it?
Yeah, the one solution is kind of a global solution. If you're happy with the way that companion object works and not much care about the syntax itself, we can just optimize the performance. So because why we posted this as a solution, because we wanted to figure out what people consider the more important aspect of it. Because as Svetlana highlighted, there are several problematic aspects that you cannot add extensions and that there are inefficiencies. And if you think that inefficiency is the only problem, then it could be addressed in isolation. We can just leave the syntax of the language as is and just optimize whenever possible all those extra overhead. That's one solution. So leave extensions alone. However, if you consider the use side is important, then there are two and three different ways to approach to the solution. What's called here the option third is basically we can introduce static members. I mean, just if you look at the top languages that are popular nowadays, most of them have this static keyword that you can add before declarations to make members static. The notable exception here is Swift, which uses class keyword, but the concept is the same. And the difference from companion objects is that if we add statics to Kotlin, then it means you don't have to group your static members in a class anymore, because right now when you write static members in companion objects, you kind of forced to group them. And we know this this forceful grouping of static members together is actually a part of coding styles in many companies, but not all. So some people actually get used to the fact that static member shall be grouped together and don't consider this as a problem. Others actually prefer to write static members like closer to the place they need it. And for them, this the way we force basically by companion objects to write static members in some block, that's restrictive. So if we take solution number 2 and just introduce statics, we remove this restriction. We let you write your static member whenever you want. And if we go this way, we'll also invent some syntax to say, I want to add a static extension to a different class. The caveat here, it won't be writing static before a function, because the meaning of static fun will be it's static in the place where it's declared. And the distinction is important because Kotlin has member extensions. So a member extension may extend some other class, but could be static in the class where it's declared. So we'll invent some other syntax to say that this function statically extends another class if we take the second approach. The third approach, takes a different route to this problem. So instead of adding a static keyword that's for marking function static, we can introduce a new concept, some kind of a lightweight object, an object without an identity. Well, tentative name is namespace, but maybe we'll end up with finding some other better name for it. Because it doesn't have identity, it's lighter weight, we can say that every class has this namespace. And then we can just say, instead of having companion object, we can say, oh, I'm adding these functions to a namespace of this class, which essentially making them static, which removes all the inefficiencies that Svetlana mentioned on the objects, but remains this Kotlin structure of having to group all these members together in some group. And also, again, with this namespace concept, this also opens a road to lightweight grouping. So instead of having to write object delegates, we will be able to replace this with namespace delegates, and to say all these things are grouped, but they're not part of the object. They are part of these lightweight things, and which can be just compiled to static members. So essentially, the difference between 2 and 3 is, so we name them differently to make it easier between us to talk, But the essential difference between option 3 and option 2 is that if we pick second option, make some kind of statics, which means we'll be able to write our static members whenever we want without having to group them together. If we take option 3, we'll retain this grouping, and both of them will let us extend other classes, either just under different name. Either we add a static extension to other class, or we extend a namespace of the other class. The core problem will be solved by both solutions.
We have some comments, additional comments in the chat about this whole thing. I can probably read some of them. There are not all the questions. So it's like there are some ideas like namespace is actually a big thing in terms of library design. It's important, yes. And if you have some specific examples and some things to add to these proposals, when you vote for the feature, you can check which solution you think we should follow. And also you can find the issue in the tracker describing all these things. And if you have something important to add, please add your thoughts, your comments there so that they won't be lost. And we usually, even if no one from the Kotlin team answers you, they are still there, and we still read them and look at them and take into consideration. There are some comments that namespace can be confusing because they clash with packages. Yes, that's something to think about, how to clearly distinguish them from the language perspective. That's of course,
and that's actually one of the reasons we tentatively picked a different name for them. So we could have called them packages, just call them local packages or lightweight packages, but they seem to be distinct enough from packages to deserve their own name. And the important thing to note, both second and third option, they do add a new concept to the language. Whether it's a concept of static member or a concept of a namespace, it's an additional concept on the language. Whatever we do, it will somewhat complicate the language regardless of the road we take. That's unfortunately inevitable in this case.
Yeah, there is also the question, so it's like some comment that it would be really useful for interop with Objective-C and Swift. And the similar question, like would they static members extension namespaces work when we tell about interoperability between Kotlin Native and Objective-C? I can just comment that Kotlin Native has no other choice, so it just works in Kotlin. Then each language feature introduced now is introduced with this idea of having different backends, and it is done like at the design phase in order to understand whether there are any problems with this specific backend or whether the design should be tuned in any way. So every feature that we are now considering is applied to all, not obviously not only for JVM, but for all Kotlin backends, for Kotlin language in general. So I think then we can go further for the next Roman. If you see any.
No, I think other questions are not for the So somebody asked that, just commented that 2 or 3 had little semantic difference. Indeed, option 2 is very close. The only real difference between them is whether they are forced to group members together. That's what we put or not. That's the only real difference beyond the name. With static members, you can place them anywhere in a class. With concept of a namespace, you still have to have a thing that groups all your static things in a class. That's the only difference.
Yep. So let's now move on to the next feature that we have, and that is called Multicache and union types. Again, we are starting with describing the problem. And imagine you process some exception that might be thrown, and you need to process 2 different types of exceptions in a similar way. In this case, we just print out failed line. Of course, you can extract it into a function or something like this, but it's still inconvenient when you have two different types of exceptions that you would like to process similarly, but in the same way. But currently, there is no Kotlin syntax to allow you to group these exception types together. There's the first problem. Another problem that connected to the more abstract problem, not of grouping exceptions, but if we take a step back and think of how overall we organize our code, that it's not, of course, when we have to deal with legacy Java API that throws lots of exceptions, especially checked ones, you need to write this checking exception code. But if you write the code from scratch, probably the way to go is to instead of throwing the exceptions, to define a result class hierarchy that contains both successful and error types as different types. And sealed classes solve this task for you. So you can define them as a sealed class, specifying what is distinguishing these options, data and failure, and then your function can return this instance of the sealed class. However, currently the syntax is a little bit verbose in comparison to how it might be written. So this code could be written a little bit nicer to solve this problem. And the first solution to this general problem actually highlights what we could do in this regard.
Yeah, so the first solution is, the reason we presented two solutions here is we wanted to see, at least partially, to see how important it for people is interop with exceptions or in Java code. Because if you're not in your particular work, we're asking for your words to know what you think is a problem, what you encounter in your daily work. And if in your daily work you're mostly working with Kotlin code, then maybe you get to work with lots of sealed classes already, and the only thing that worries you might be the verbosity of their declaration. And the first solution is to solve just that. We can take syntax of a sealed class and more enum-like. So instead of verbose declarations, you can just write the cases and their parameters, and that's it. And that doesn't address the caching problem, but again, if that's not the problem you're facing, that might be the solution you would like to get as a solution. That's for first option. And the second solution is to actually go further and try to solve both multicache and for exceptions that might be coming from exception abuse in Java code, and at the same time give a linear and light way to return multiple types for a function by introducing union types. And the reason is, if you look at Java, how Java does it, Java have actually the syntax for catching multiple exception, but it has this special syntax that supports it just in the catch clause, which is, some people ask, and I already say, so why don't we do it just like Java? It's not that easy to do just like Java in Kotlin, because Kotlin is different language, it's different type system, and it's quite hard to hack from type system point of view, just to hack this special case where what is E if I catch either IO exception, age, DOM, what it is, what type it has. In order to, teach Kotlin compiler what this thing is, we have to introduce this concept of what is technically called union type in Kotlin anyway. And if we and our reasoning from the language design implementation standpoint goes, if we introduce this thing into language anyway, why don't we allow into other cases that make sense? In the other cases that make sense, it's function return type, because I just want to say this function returns either this or that. That's a union type. And that would be a solution to both problems, both to Java interop and to writing clean content code that clearly specifies that this function can return either a result or a failure. And the question is, how can we prevent their abuse? There are different ways to prevent their abuse in the lecture. First of all, we don't have to support them like virtual everywhere, but though we'll probably end up supporting, if we add concept of unity, it will end up supported everywhere in the language ultimately. And of course you can't the only way to prevent abuse is through code style. Like every language feature is potentially abusable, and we can't put arbitrary limits into language. Say you can only say return union of 2 types, but cannot limit it to 10. That would be weird. But we can make inspections, make style recommendation. Please use union types for this and that. And it's also, some people get scared by union types because, for example, you look at JavaScript ecosystem, it uses lots of union types. Functions take either of a big set of types, they return some dynamic things that can have different types, etc., etc. And some people get scared, like if we add this to Kotlin, will we end up like JavaScript? And I'm not really sharing these fears because in Kotlin, first of all, we will be forcing you to always write those union types. So the solution we have in mind in this direction is that if we introduce union types, we won't be automatically inferring those union types. We will only support them if you explicitly write that I am returning or using here in union type. So basically, we'll force you to write it down every time you use it. This kind of places a limit on the abuse you can get from it. Like, okay, you can use it, but then you'll have to basically write this. Yes, you can write type LSs, but again, basically, if you'll have to expend some, unlike in JavaScript, where you can just don't have to write this type at all, and it's very easy to get very dynamic and get a function that returns 3 different types. In Kotlin, you'll have to write them all.
Yeah, but just to highlight that it's not the final decision that will add union types to the language. I think that this question about how to prevent their abuse is actually the answer why Kotlin hasn't added this union types, because I do remember that even before the first stable release, there was lots of requests and some people said that, union types, I need union types, why you don't have them, and so on. So whenever ideas you have, whenever use cases, especially use cases you have for this, and whenever fears you have that it might complicate the language and it might abuse the language, please share this with us. We have this free forum in the forum, or just under the issue. It's all very valuable. So it's like everything we are talking about. It's not that it will be 100% implemented in Kotlin. There is this goal of actually gather general feeling, different opinions, different use cases, more pragmatic, practical use cases from your side, and so on and so forth. So yeah, please share all this with us. Yeah, but I think that union types is really the thing when we have 2 different camps, probably one for union types and another one saying that too complicated.
Yeah, so some people get scared, but again, I'm not. For me, it's what's stopping us from adding union type. It's not that I'm personally scared that they would somehow get abused. And Sveta mentioned that we don't have since version 1, and we can already shown to everybody that you can write great code without union types, which is actually a good thing because we already have Kotlin ecosystem that's not relying on union types in any way. So even if we add them, this kind of will serve a natural limit to the abuse because people have already learned, and we have great Kotlin community that have already learned that you can still do great APIs without union types, and that's kind of a good thing when you don't add a feature from the very start and add it later. It's an actually nice trick because you've already shown people that they can live without this feature, and they will use it only when it's absolutely necessary, without abusing them here and there just because they had it from the day one. And Yeah, it's somebody asked that. Yeah, it's actually, in fact, Kotlin compiler internet almost already supports unit types. I mean, it has all the ability. So technically, it's not that hard to add them, but it's still a lot of work to add them correctly and test them. And that's kind of the main stopping factor. Every feature, it's maybe a little bit of syntax, but there's a lot of work inside compiler to properly support and test it.
I like the comments that there is already discussion what is nullable type. That's the union between type and nullable nothing. Yes.
Yes, it is.
Yes.
And yes, and that's why the reason Kotlin type system kind of only supports unit type, because nullable types are essentially unit types of very limited form.
Yes, and there are some, and actually in smart costs, they also might appear. So good. Then I think we can move on to the next feature. Let's look what we have next. It is a very simple one, package private visibility. And the problem description is there is no package private visibility in Kotlin. That's it. So historically, historically Java package private has this hole that if you define the same package in another module or in another compilation unit, you still can access the member in the package, which kind of breaks the visibility to some extent. And we wanted to fix it. And in Kotlin, there is no package private visibility. There is you can either define a member as a private, that means it's available in the same file, or you can define a member as internal, that means it's available inside a module or in the compilation unit, but there is nothing in between. So some folks would like to have it from the Kotlin perspective, from pure Kotlin perspective, and also there is a common problem still when you have mixed Kotlin Java projects. It would be convenient to define it as to have this modifier. And there are two different interesting solutions to it. Possible.
Yes. So the one solution is just to go ahead and add this modifier, just like in Java. The obvious downside to it is just, it adds the whole another modifier to the language, which, you'll have to write. And because, again, we're not talking about changing defaults. And somebody already actually asked before we came to the question, like, wouldn't we consider making classes package private by default? And the answer is that we don't have any evidence that that's a reasonable default. Actually, all the evidence we had before Kotlin 1 and still have is that public is the right default, because that's what that's what is most commonly used in the real Kotlin code. And our policy on defaults is very simple. What people use most often, and that should be a default. So we're definitely not, if we introducing new modifier, that will have to be, unlike in Java, explicitly specified, like package private blah 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 function, will be probably long, and whether and it will be a separate modifier would solve the downside that Sveta mentioned, that even though in module with module system in Java it goes away. So like if you write module jars, you can then make sure no one else can add or access declarations from your package, which just kind of makes safer now. So that's the reason to actually consider adding this modifier. But again, that's complicated the language. It's now a separate one more modifier people will have to learn and know how to use. The other way is, the second approach is different. It stems from the following observation. From what we can see, the reason people ask for internal is that they want to control. So they have this complex project, and they have different architectural layers. Like there's my services, there's my data classes, etc. And they say want to share some utility methods between data classes, and they don't want them to be accessed from other packages in their architecture. And in Java, they would just write a package private declaration, which we don't have in Kotlin. But conceptually, if when they do this, what conceptually happening is they treat their data classes it's not just a package, it's essentially a separate module in their architecture. But the problem is the way the ecosystem we live in, with all the build system we have nowadays, whether it's Maven or Gradle, creating a module in your build system pretty heavyweight thing. So you could easily have solved this just by creating a module for data classes, and then internal declaration in this module would be visible just to data classes. And people are reluctant to do this just because creating module build systems is a heavy thing. You know, it requires lots of effort. You have to create, build Gradle or Maven file, copy some thing, create a multi-module build, lots of complex steps to make. Makes it's all heavyweight. So, and that's where the idea for second solutions come from. If that's the main use case for interdeclarations that people are concerned about, then we can solve it on a language level. We can say, instead of creating a module and build system, you can mark your package as a kind of package module. Say that this package constitutes its own confined, isolated micro module, and then without introducing any new concept to the language itself, just then all internal declaration in this package will become isolated to this specific package. That's it. No new concept to the language, just ability to say, explicitly say, my data package is separate module. My services package is separate module that's isolated from the rest. So that's the idea behind second solution.
Yep. Thanks. Again, if you have some preferences, especially with some additional comments, use cases, and so on and so forth, please share with us. Of course, there are some, as usual, some pros and cons for each solution, some downsides. Every time when we are talking about introducing a new concept, it complicates the language, and some other solution might not solve all the requirements. So that's always about finding the right balance. And from my perspective, so far, it's all good. It works quite well. This idea of finding the balance, but yeah, I think that's the major thing that all the Kotlin designers are working on, is finding the pragmatic balance between different options. Okay, as I see in the comments, we still have the discussions about union types. So I'm not sure we have any questions about this. But yeah, I think that this package private thing is quite straightforward. So we can probably move on and discuss the next feature. Again, something that I do recall some discussions before even before 1.0. So this idea of having multiple receivers lives for very long, but there is always this question of how to implement it, right? And I'm really happy that now we are probably soon kind of staying close to actually have it finally available. So let's discuss first the problem. In Kotlin, you can define an extension inside a class. It's called a member extension. It might be a property or a function, and it has basically two receivers. So if you look at this, in the body of this function, we can call both these receivers. And when you call this function, Kotlin scope functions like with or apply or also allow you to introduce this implicit receiver to the context, so that you can call your member, your property or function as a usual extension. But they kind of require having this receiver in the context. So we already have something like we can call this declaration only if this additional implicit receiver is available in this context. And currently, there is this constraint, then you can only define it inside a class. So if view is a third-party class, you can do nothing. You can't use this syntax. And if you want this view class to stay clean and short, and you would like to move this to extension, it works for regular classes. Like for a member, you can decide whether it suits better as a member or as an extension to a class without having too many members. For this case, you currently can't do it because you have you can't define an extension to more than one receiver. So that's the problem. And there is a very interesting possible solution to it.
Yeah, so the solution we've been spent recently quite a lot of time, and that was our roadmap actually figuring the Kotlinish solution to the problem, and we came to one. And the solution we came to is to introduce the concept of contextual receivers. So in addition to a primary receiver that you specified before, a receiver that you will be calling this property or function on, you could also specify contextual receivers that can be explicitly specified on a call side, but always come from the context. And since we've kind of already figured out what solution could be for Kotlin, you would ask, why would we even add it to this voting list, like if we already figured out the solution? The reason we actually add it for because we want to figure out and want your feedback on how you think solving this problem is important, because even though we've kind of figured what the solution would look like, it's will take a lot of work to cleanly and completely implement it in the language with all the IDE support, with all the backend support and stuff. And so your feedback on the importance of this issue is important for us to figure out how to allocate our resources to solving this problem versus solving some other problems that we have on our plate of the language.
There was a question, I think at the very beginning of the chat, how to call this function defined as a context-dependent declaration, and the answer is like as before, nothing changes. So you still can use it with view. The only thing that this context receiver should be an implicit receiver. So you can't call it explicitly on it. But overall, the syntax to call such functions is already here. So we already have it in the language.
Well, yeah, always for member extensions. Yeah, no difference from member, because if you look at this slide, the member extension DP, that is actually two receivers have their own name. View is called a dispatch receiver, and float is called an extension receiver. And right now in Kotlin, the extension receiver float can be explicitly specified. You can take a float dot DP and call it, but view dispatch receiver cannot be. There's no explicit syntax to call member extensions to explicitly specify a dispatch receiver. It has to be in the context using with, and we have the same plan for those contextual receivers. Whenever you call them by design, I mean, and that's kind of drives when you are designing functions what should be put in the context receivers and what should be put as an extension receiver. An extension receiver, so when you design a function, you have to think what this function operates on, and that should be its extension receiver, and what this function requires as additional parameters, and that should be its context receiver.
And there is also the keep document, I think, for this, where you can also check some kind of reasoning about when it should become this context-dependent declaration, when it might become the member extension, or regular extension. So, of course, such change requires some kind of reasoning about what then becomes the idiomatic way to write this stuff. But there are some lots of ideas. And again, if you have something to add, please do.
Yes, and the people also ask, will it support multiple? Yes, and the idea, of course, is the syntax is designed so you can comma separate multiple context receiver, and you don't have limitation of how many is to specify. And the reason, I mean, again, so to mention, there is a keep document that goes in all depth on why this syntax, why not other. But a short comment: the mental model for context receiver is just like parameters. which is implicitly. So that's why the syntax is kind of parameter-like. So there's those braces around the list of receivers, which resembles the list of function parameters. It's just they don't have names because you pass them implicitly, which kind of, again, intentionally so that you understand, because they don't have names, they kind of unnamed and implicitly captured.
Yeah, and also there are some comments with some syntax proposals, like let's do it like union type as a receiver dot declaration name. Unfortunately, it's too confusing. It's too confusing with union types. It doesn't clearly represents what's like the difference between these two kinds of receivers. So this proposal is kind of a work of thought of how to make it consistent with the current language, and with also add these possibilities and clear guidance when to use it. So it's not that simple than just to use this several receivers in the receiver function declaration. But I do recall the syntax. It always comes up whenever someone talks about multiple receivers. There is every time there is this idea. Okay, let's just list them as a list in a comma with some other syntax and say, okay, this is our receivers. Yeah. So this proposal tries to solve this problem and don't introduce new problems with confusing the syntax.
Yeah, I mean, there are people still asking questions, but since, again, most of those questions are answered, actually all of them are answered in the keep, and you can, I think we should rather move on, because, I mean, I think for people who are interested in details, just go read the keep, and it answers all of your questions for sure. And we'll rather spend time in this seminar on some other features that don't have as detailed design and might indeed have genuine questions that are not answered yet.
Yep. So you can find the link to the keep in this survey when we have the blog post describing the features, and specifically this one has the link to the keep. But I hope that our audience already knows where the keep is, what is it, and how to find it. So yeah, please go there and check. Then let's move on. Then yes, the next feature is a known. Kind of a known point of complaints from the Kotlin community that, yes, of course, you have this cool feature, Namebased Destructuring, that works well with some of the cases, but with some other cases, it doesn't work that well, and there are also kind of advice to avoid it. So what's the problem? In Kotlin, you can use this so-called position-based destructuring when you assign a variable into several, or an expression in general case, into several variables, and the Kotlin compiler automatically assigns different components to different variables by their order. And it works great for library classes like pairs or tuples. However, for your own defined data classes, it doesn't work that well. So for instance, in this example, we defined data class address and destructured it into two variables. But afterwards, we decided to add a new property, but not at the end, but in the middle of the class. And then our position-based destructuring breaks because now the second property gets assigned to the second variable. Remember, it's position-based. So the first goes to the first one, second goes to the second one. And that's really is a big problem, and there are some advice like don't know about it, don't try the code like this. IntelliJ highlights this issue and notifies that probably you have a mistake here because you assign it to different variables or stuff like this, but still it is not prevented at the compile time, and it's a problem that just should be fixed, and there are possible solution to it.
Yeah, so the solution generally is to add some new syntax for name-based destructuring, which is actually present in some other languages. Many languages with name structure has some kind of syntax for destructuring them by name. We can't just take their syntax as is because Kotlin syntax is different than what we naturally But this slide shows just one potential syntax that kind of Kotlinish, that mimics the way you pass name parameter to functions, and we could just take a similar syntax it uses for name destructuring. And with name destructuring syntax, since you'll be specifying it by name, you will be immune to the problem that adding names later breaks something. And that actually, this syntax actually opens the road for us to make positional destructuring for classes opt-in. Because right now, whenever you make a data class, we automatically support positional destructuring for them. And for some classes, it does make sense. Like your class is conceptually positional, like pair. It has a first, second component. And you kind of say it's only positional, those names kind of arbitrary. But some lots of business domain classes, like the address or username, which might consist of multiple components, for them, their order may not have any business value. Only names might have a business value. So it makes sense them. And it turns out those business classes that are name-based, actually, if you look at the real code, they consider the majority of your code. And the kind of position classes like pair, map entry are kind of minority, the usual library classes that you have a few and they're enough for you. So it opens the road then to say, okay, let's make then by default change so that when you declare data class, it's only works with name destructuring. And if you want it to be positional destructured, you have to opt in. So that's a solution we have in mind into this problem. And people also ask, do we consider like nested destructuring? And in our mind, solving the name destruction is prerequisite to nested destruction. Like, so right now in Kotlin, we have this limited destruction capability that is positional and limited to one level. And we already know it suffers from problems. We don't want to double down on it, make it even more complicated. So like supporting nested cases until we solve the core problems and have. So in our mind, this has to be solved first. And then we can consider additional extensions like nested, destructuring, etc., etc.
Yeah. There are some comments about syntax. It's not final. So if you have some comments, come and share why one is confusing it. So it's like this analogy was meant to be as an analogy to function named arguments and parameters.
Yeah, and the reason why it's left-right, it was meant to mimic. The reason this syntax is spelled this way, because when you see destructuring meant to mimic, to be opposite to constructing. So when you construct or call a function, you can specify parameters either positionally or by name. And now when you destruct things, it looks like a pattern. So like you say val x, comma y equals something. It's like give me a pattern for things that you would otherwise have passed to call. So the syntax on the slides kind of takes this pattern-like approach. So let's take Kotlin's function call syntax with name parameters and use this as a pattern to match on the. So basically, you would read it as this: take a call that with street equals some placeholder and city equals some other placeholder, and kind of pattern match it to the address.
Yeah, but again, if you think that is confusing, please come to the comments and share that you prefer this syntax is still available to making the final decisions on what syntax it might be. There is a question how it should work with components. So like functions, component 1, component 2, etc., component n. They are not needed in this case because the destructuring is performed by names. We no longer need this list of component functions. They are needed for positional based destructuring, and this should work with just applying for the constructor names. So yeah, any syntax suggestions, you can post them in the chat. We'll ignore them in the chat here. You can post them in the issue, and then they will be taken into consideration when this feature is finally designed. We'll see it's like your feedback, and if many people will come and say, no, it's very confusing, then surely Roman might change his mind and swap them. But we'll see. Probably in a year we'll find out what is the final syntax for this. But yeah, you can still impact on this. Okay, so I think that I don't know whether we have any questions. Combining name and positional destructuring, I would say no. There's this question, what about combining named? I would say they are different. It's like either way by another, but on the other hand, it's like we allow combining named and positional arguments for the function finally after it's like after some time finding out that it still works. But I would say that in the first version, it probably would be definitely either positional or named, and then
and I see lots of confusion people have about syntax. So syntax will be definitely a hard thing for this particular feature, and it basically boils down to what prior experience people have. So for people with Java experience, probably they first see this kind of syntax, they probably get utterly confused because Java doesn't have right now anything like that. But for people coming from some other functional languages that have pattern matching syntax, it might look like completely natural, with the exception of maybe using different characters. Like because see, if a language uses, for example, colon to specify name parameters, they would also use colon to pattern match on a name basis. And I mean, the reason this syntax is chosen for this slide just because since Kotlin has equal sign for calling functions with name parameters, like the go-to default would be to use it for the name destruction too. But again, the syntax will be definitely hard thing to find an isolate for this feature. But again, what we're voting here, it's important to note when you vote for this feature, doesn't mean you approve this particular feature. Is your vote goes to say this issue is important for me, and then we'll take it into work, and then we'll start working on syntax, and maybe even if it turns out very contentious, very hard to figure out, maybe we'll have a completely separate vote on what kind of syntax you prefer for it, or maybe not. Maybe we'll just figure out the great syntax that understandable and fits Kotlin.
There is one more question about what will happen to list destructuring. So the position-based destructuring, it can be removed, so it stays. The only question is that it can be not be default for data classes, but that's a specific story for data classes. But for library classes that are stable, like pair or triple, or even for list when it's convenient sometimes to destruct it into first elements, it stays. So nothing happens with this. It's not that this feature replaces the position-based destructuring. It just replaces it in this very specific confusing use case of evolving data classes. But if you have your pair in the class, you shouldn't be worried, and you don't plan to add more properties. If I'm not mistaken, Roma, you can check. I think I remember it correctly, but I might be wrong here. There is a question: which feature was the first one in voting? And I think it's this one.
Yeah, that was last time. Last time we get survey collection literals were the most voted feature, exactly. But they were also the most controversial. I mean, it's the feature that got most votes for and most votes against. And I mean, and I think the reason the last time it was controversial because we didn't really explain what we want to do with it. We didn't really explain the solutions, and some people thought that we will do some crappy solution, and they don't want any part of it.
Yeah. So let's first discuss the problem. What's it about? So what are the problems with the current ways to create collections? So because collection literals is actually the syntax, the specialized syntax that is used in many different languages for creating collections. So what's the problem? It's verbose for data-heavy applications when you need to create lots of collections. And it wouldn't probably be such a problem, but also there is this built-in inefficiency because these library functions use var args, and that's not the most effective way to implement the collections creation. And that's probably one of the important reasons why it's still on the table. It's still on the consideration as before. And also in the current way, you really like the type of the created collections is defined by the constructor you choose, which is also sometimes not really convenient, and it would be nice to probably specify types explicitly, which the proposed solution can do.
Yeah, and the solution we have in mind for collection literals is, first of all, invent the syntax, but the important thing will definitely not go into hardwire this syntax to like list and maps, or definitely not to arrays. Some people know that in Kotlin annotations, you can already use this collection literal syntax. You can you use square brackets to specify arrays. And that actually one of our theories about so much negativity of the proposal to add collection literals in our previous survey comes from the idea that some people thought, oh my God, collection literals will be creating arrays. I don't want arrays, so I will vote against them. No, that's definitely not what we want to do. We want to add collection literals that are flexible in the types they create, where just like for other literals, actually Kotlin has number literals, functional literals, and their actual type depends on the context of their use. Depending on which context you write a lambda, for example, if the context supposes runnable type, you'll get an instance of runnable. We envision the same for collection literals. Depending on the context of where you use the type, will create a collection of an appropriate type. In annotations, it will create an array. If you call a function that takes a list, it will create a list. If you call a function that creates some of your custom type, it will create your custom type. And so that's the key point of the design. But just like with function or lambdas in Kotlin, they will have a default type. If no type is obvious from the context, there will be a default type, like function n for functions. And those default types will, of course, Kotlin's lists and map, which is what you usually work with in a Kotlin code. And then because it's driven by the expected type, you can enter specified type on the left-hand side, or you can, of course, just will naturally can write on the right-hand side that you want collection of this on this type. And of course, will be flexible in what kind of course, like on the fourth line where you create a set. You don't have to say that it's a set of integers. You can just write, I want set. And the fact that set of integers will be inferred completely by the type system.
Before we move on to the next slide and to the underlying implementation, I want to briefly answer one question. So there is a question, how is set with square parentheses better than set with round parentheses as it is now? And I think that the last line of this slide is the answer to it. Because you see that you can specify this expected type, and this expected type defines the type of the literal of the collection that is created. So if you have set of lists, I don't know what are these data heavy applications when you create like this nested lists or nested collections. And for this use case, you specify type once, and the right collection literal, the right type of the collection literal might be defined by the compiler from the expected type. Currently, you have no choice. You still have to always write all these types for all the nested lists or sets explicitly, and that's why it's different. It's much more concise for these cases.
And I think there's another. Do we have another slide on the solution here?
Yes. So now we have this underlying implementation slide. Mm-hmm.
Yeah, and of course, to solve one of the core problems that it's right now list of is inefficient, as realized on Wargarg, the plan for collection literals is to desugar them into efficient and builder code that creates the corresponding collection that is properly sized to the number of elements that have been specified in the source code, and just adds the corresponding elements to them. And again, it will work both with built-in types and with any custom type that you have. So that's the plan for this feature.
Yeah. So there's was a question: was it able to use this syntax to new collections built by custom libraries? I think that's meant by custom libraries, and the answer is yes. So it's like the idea is to make it kind of general way to and give this also this option to define your own types. Okay, briefly checking whether we have any more questions to answer, but I think we can move on with this and discuss another literals. Another thing that exists and under the, I think that actually at some point tuples were present in Kotlin, but then it was dropped before.
Yeah,
the
tuples were present in Kotlin before 1.0, and they were dropped. And the reason they were dropped because, and actually, I will tell later. You talk about the problem and
yeah. So just the problem is very brief. So it's like in many different languages you can define. Actually, there's a good question: is it tuple or tuple? Because the English dictionary says me tuple as a word for tuple, but I'm not sure that is the same pronunciation for the concept. Ramos, you vote tuple.
It's tuple. It's tuple. I think it's tuple, but okay. I may be wrong.
If you know the answer, you can write in the comments and teach us how to say tuple or tuple. So okay, I will go on with tuple. So it is just a finite order sequence of elements, and in many languages you can define it as some literal, and it represents this just collection, finite collection of kind of a sequence of elements, and that's it. And in Kotlin you have pair, you have triple. But we don't but they are library classes. It's not like a built-in syntax, and it's not that they work for more than 2 or 3 elements. So this is the first problem. Kind of the general request of support these tuples in the language, again, exists for many years right now. But if we continue our vision with simplifying the data creation for data-heavy applications, we already have in mind this syntax for collection literals. And by the way, it is used here. So these square brackets are this syntax for collection literals. It would be nice also to be able to define the same thing for custom data classes. And also, if we don't provide it, then you might be keen on using this collection literal syntax for this use case, which is not a good idea. So probably it makes sense to support both of them if we support them. So in this case, the second line is just is intended to create the list of points as the first line. So yes, here point is a data class. We assume that it's a data class. However, in this case, probably you should you additionally specify that it can be used with the syntax. So it's not general data class, but that's a separate question. The point here is that the idea here is just to provide this ability to create some simple data classes with some additional data, or without some simple data classes with this concise syntax. Currently it's verbose, but it might be supported. So then different. Okay, Roma, first the story of why it wasn't supported in the first place.
Yeah, and first of all, it was supported before Kotlin 1.0. Tuples were in the language, but the trick is that they were supported just like shown on this slide, in slightly different syntax. It was hash before the opening brace, which is irrelevant. And the reason they were removed shortly after data classes were introduced. The reason why they removed because tuples do solve important problem that Sveta mentioned, they're extremely prone to abuse. Like people get quickly carried away and start writing their code with tuples. As somebody mentioned in comments, as soon as they got 5 or more elements, you forget which one is which. And actually, it comes way before 5. The reason is Kotlin standard library has only Kotlin standard library doesn't even have a tuple for 4 or 5 elements, and only have pair for 2 and triple for 3. And even triple, I often find confusing. I've seen Kotlin code bases that even right now we don't have tuples, we only have triples, and even with just a triple, I've seen a code base that abuses triples and pairs so much that code is completely incomprehensible. Like every function is declared to return a triple of integer, string, something, boolean. It's completely impossible to figure out what this function does, what was the intent of the author of this code. And so, I mean, even though we kind of solved it, but we added then pair and triple to the standard library, so people still abuse them. So, and that's why we can't just add tuples to the language. We have to have mechanism to prevent this kind of abuse. And there's a second slide for that.
Yes.
And of course, if we add tuples to the language, we have to support name components from the university. Maybe even we have to forbid defining tuples without component name. That's debatable, or place some limits, because unnamed tuples it makes code a completely unreadable mess. But tuples with name components are not that much problematic, because and they actually help you to nicely and short write code, for example, where you have a function that in ad hoc ways returns a pair of values. And right now you either use a pair which has components named first and seconds, which has no relevance to this function, or you write a data class that's kind of specific for this function, which also doesn't feel right. Like if I'm using only in this function, why I have to declare a data class? So the tuple with named components is kind of like anonymous data class. So instead of declaring data class and figuring out how to name it, how do I name this data class? Parse next into result looks like a boilerplate name. Tuples would define those anonymous basically data class in an ad hoc way in the places where I just need them. And of course, it will play nicely with named destructuring that we've discussed 2 problems ago.
Yeah, so that's the rightful discussion in the comments that right now an alternative for this is obviously create a data class for this parse next in function, specifically returning this result. But the better way, the more clean way, might be not to define this separate class, but to return this named pair directly. So you can right now return a pair, but it's like pair int. It's not pair value and next position. So these are all considerations about why it might be useful. Again, if you have any comments, any opinions on this, it's like survey is still available, and also the comments in the issue. There is a question how one can compare two tuples with the same types. So I think that if they like on this second line, we have this, so it will be different tuple types. So it's like the types should contain the names. But if you have 2 types with the same names, like X and Y, then they can be compared. And then I think they just can be compared as data classes by comparing data. But that's all to be...
Or maybe not.
To be designed.
Yes. Actually, in fact,
yes.
Yeah, there's lots of details in tuple design that again that we don't know yet answers to. But I mean, the purpose of this questionnaire is to figure out what problems you think we should be working on. And of course, if we start working on tuples, we'll definitely tackle those design questions.
What about 2-component tuple without named parameters? There is
well, you have it called. It's called
yes.
pair.
And also, it's like in this case, we still have this idea of defining an anonymous tuple without named parameters. Yeah, but there are all these are questions. It's like how to make it work and useful and ideally not that much confusing without providing too many ways to abuse. There was this, I think there was this question in the chat about data classes and positional name destructuring. Why couldn't you do it right from start? It's like, if you knew this problem will appear, why could you not introduce positional destruction for data classes? And I think the answer is that it's like it really demonstrates this complexity of language design. It's like you try to predict the problems that might appear, but it's not always possible. And for this, we especially need your use cases and your thoughts about like trying to play with this, with all this functionality, and to try to predict some problems that might appear. So yeah, that's all difficult tasks. So I think that now we, I don't know, Roman, do you see any questions that require your
I mean, yeah,
comments?
there's lots of questions. I mean, it's kind of questions that all go around, whether we really need tuples, whether people will abuse. I mean, and that's key question about tuples. Like, it's balancing the useful things they will enable or writing better code versus potential abuse. I mean, that's really. I mean, I think that's the hardest actually decision in language design, when you see a feature that clearly has some use cases, and use cases are easy to demonstrate, and then it will be abused. But kind of judging how this abuse is, whether it's going to be really bad abuse or is going to be minor abuse, that's really a hard judgment to make. But still, the use cases here are the main driver. So if like a feature has lots of use cases, we can tolerate then some potential of abuse, because abuse can be covered by code styles, by inspections, by warnings from compiler in some questionable cases, etc., etc. So one thing we really need from you, in addition to your votes, is of course use cases. So if you have some in your particular project, if you really need this feature, and would really help your code, the kind of code you write, first of all, vote for it. The second, go to the corresponding issue and share your use cases with us. Why, for your particular code, this would be a great feature to have.
Yeah, and also your comment, your doubts, and your fears are also very welcomed. So if you find that something will complicate the language, or you would prefer a feature not to be added, you see different ways to abuse it, also please share with us. That's all very valuable feedback that you can share with us. So I think that we go on and we discuss the next feature, which is about public and private property types. Probably you already know what's it about, because I think Roma shared this exact feature on the plans of Kotlin 1.4 event, something like we want to implement this feature, but yeah, it was added to the voting to gather some additional feedback. So what's the problem? The problem is that you can't specify different property types to be used inside a class and as a public API. It's like there is no syntax for this. And the current workaround that many people use is to define two properties. The first one is public, that returns you, for instance, read-only list. And the second one is private, that stores mutable lists inside, and they are basically just one property. So this public eval with getter just changes the type of the property. And the question is, why not to do it in one line?
Yeah, and I mean, the solution is obvious here. The reason we're asking this, first of all, is we know we want to get a feature in upcoming release. And again, as Svet mentioned at the very beginning, worth repeating, this is a priority list we're getting for future releases. And what we'll do is for 1.6 all is set and is public in our roadmap, so you can check there what we're doing for 1.6. And the reason is, though this feature, it looks simple on the surface, it's a pretty complicated front-end feature, because it adds new dimension previously unexisting to Kotlin's resolution process. But right now, if a resolution resolves a call, it can figure out what's the resulting type of the call or property access without having to figure out like whether in the same module or in the same class. It's not tied to access, like the type right now in the Kotlin is not tied to the where you access it from. You may be allowed to call it and not allowed to call, but that's a different checked in the compiler on a different level. There's a checker that would give you an error if you're trying to access a private property from a place where it's not allowed to be called from. But this feature, even though it looks simple, it adds a completely new dimension to the Kotlin resolution process. Now, in order to figure out what type this thing has, the compiler will have to figure out where it's accessed from, and that's why it's not something we can just implement in 5 seconds. When we've looked at this feature, we knew it's important. Well, when we look at it with the team, we've estimated for it a pretty significant effort in the compiler front end to implement. That's why we need your feedback on how it's important to you, to see if maybe there is something more important we can spend this time on than this feature.
Yep. So I think that we also want to have some time to answer your questions. So now here will be the last feature which we describe. So there are more in the survey. You can find more details. We just picked up some of them, probably the most interesting ones. And right after this last explanation of the last feature, we'll also devote some time to answering questions that we had previously and also from the chat. So this last thing is about unqualified constants and sealed subclasses. So what's the problem? There are two similar connected problems. So let's discuss them one by one. The first one is that you know that when you use the constant name in one expression, when you iterate over constants, or anyway, when you just use the constant name, the only way to use it by name without the explicit specification is to import it. So it's like, I need this import my package.color.constant names or everything from the class in order to access these constant names in the test function. And that's sometimes, often not very convenient. And there is this issue, and also like for very short names that might clash with other constants like on and off, this importing them just by names for the whole file is undesirable. So it's like, it's not that you just can access these constants or these members inside a scope. When you import them, you can access them everywhere in the file, and sometimes you would like to avoid it. But yeah, that's the only way how it works right now. And the same works for subclasses of a sealed class. Again, if you have this one expression, you enumerate different subclasses. Again, there is two ways to do it. You either need to import them with the same problems as before. They just are available in the whole file with the same problems with names. So probably for some cases it's better to write it explicitly, but in the context when you would like to shorten them, it's not possible. So there is this suggestion to solve it and actually to introduce a rather extensive functionality, I would say, a rather big change to introduce this context-sensitive resolution for names. So what's it about?
Yeah, the idea is conceptually very simple. There are a lot of context in the Kotlin code where the type is known from the context. Like for example, when we have when with subject, and when you write this line, red arrow pointing right, in this context where the red appears, compiler knows that we expect the type of a color. Or for example, in the color function, we know what type expected. There are many places where type is expected. And or for here, we know that we're checking for something that is subclass of user result. So the idea is in those contexts where the type is known, we can assume that import is there. So instead of requiring you to go and import it, we can assume you've imported it. And the nice thing about it is that imports in Kotlin has the lowest priority among through the resolution process. So this would be totally backwards compatible change. It will make the existing code that does not compile, will make it compilable. But if this code already compiles because you have red defined locally or already explicitly imported, then it will still continue to work as before. So this auto context sensitive resolution will work at the lowest priority level. Only when otherwise code wouldn't have compiled, it will see, okay, let me try to see what is the expected type and assume that we already imported this stuff from this type. See if now we can resolve this call. And this basically works just like if you've imported it, but without you having to import, which is especially great for short names like on, off, red, blue, because like on, off, you have multiple enums. You have, for example, your application may have, connection mode, which is on, off, may have, some other modes or some other enums that also have on, off constants. And with imports, then they will clash with context-sensitive resolution. You can use short names in the particular context without any clashes.
And we have also an example with function here, not just with constant.
Yeah,
name.
and since we'll be general solution, for example, if you write, for example, in Jetpack Compose, which has this pattern for modifiers, where you write modifier equals modifier dot something, it likes really a little bit like a battery right now. And with context-sensitive resolution, because in the context of modifier assignment, we already know the expected type of being a modifier. Compiler can look up because there's no preferred height in otherwise available, compiler can assume which is imported everything from modifier and then find the corresponding preferred height call. So it will read just like the code with import, just without you having to write one.
Yep.
And in so people, I see Swift mentioned in the comments. The feature would be kind of similar to the way it works with Swift, though the syntax is different. In Swift, you have to write dot for this context-sensitive import, and we don't need this dot in Kotlin. First, implementation standpoint, it wouldn't feel Kotlin-ish with dot, because in Kotlin, when I import something, I don't have to prefix with the dot, just write the name, and it's essentially auto import in. So why would you have to write a dot?
But it could have been Swiftish in Kotlin, adding some feeling of Swift.
Yeah, but that's
we don't
the general problem with this. Yeah, but it's important question about how do you add features to the language. Like people often come and say, I want, please add a feature like in this other language, in Swift or Java or in C# or in Python. And it doesn't work this way. You can just take a feature from another language, add to Kotlin, because it wouldn't feel natural, wouldn't fit all the other features. So when requests like that come in, first thing we'll try to do, okay, well, what problem you're trying to solve? Let's distill this problem, what use cases you have, and then find a Kotlin style solution to the problem you have.
Yep. So I think there is no problem with I think Kotlin is similar to many languages, and that's good, because going from many languages you find some similarity, but still every language has its own feel, its own kind of idiomatic style to write things, and also from the design perspective. So I think that I haven't found any questions specifically about this feature. I think we can answer a couple of pre-posted questions We still have 5 minutes. Before that, I will briefly remind you how to vote. That's the survey. That's easy. And also we had a question. Why don't we include a question what existing functionality should be deprecated or replaced? If you have anything in mind, we have this free form for any other comments that you might want to share with us. so just share this information with us. And also this survey asks you what feature you would like not to be added from this list. But again, you can pick up anything that already exists. We have the whole description of these features that we already discussed in the blog. So you can, and we also shared the link to the KEEP document describing something. So you can find all this information. And now I think we have 5 more minutes for Q&A. We'll try to monitor the chat. So if you have something general, post it there. But we can't promise we'll have time for it, but we'll try. And I have one question for Roman, which is kind of so someone asked it in the forum, but then it can be reformulated or reworded in more general sense, and I think it's a very good question describing the Kotlin philosophy to some extent. So the question was why it was about something that we haven't covered in this webinar, but there is another proposal to add overloadable bitwise operators. And there was a question why, when we talk about adding some new operators, we are talking definitely about making them overloadable and not just adding bitwise operators for booleans or something like this. And I would like to a little bit reword this question. So why it's in general important to make and there is this desire to make the goal to make the features kind of abstract, so that there is just general solution. So for instance, when we discuss we discussed structural literals. So we say that yes, there is structural literals, but we want to provide this way to for the community to use them for libraries. There is also this example of context-sensitive resolution. I don't know if it's supported, then it's supported in every context. And I think it's a very important question about the language design. So, Roma, could you please comment a little bit on why can't we just add something for a specific use case and it will work?
The problem with language design is that in Kotlin we try to maintain a balance, a really clean balance between core language features and libraries. So we try to minimize the number of core language features and maximize these things that are done in the library. Some, like if you look at types, even there, like sometimes definitely like Boolean type, for example, it definitely tied lots of language, and there are some operators for Booleans that are non-overloadable. But if you look at how, for example, integers work in Kotlin, even though we have integer literals that are part of the language, like most of operators on integers are not really part of the library. They're just library functions that are available on integer types. And that feature of Kotlin makes it friendly to various domain-specific languages. So it means because we did not bolt them onto the language, but make them overloadable, it means you can take your custom integral types or numeric types and define your own operators on them. And the code you write would feel as if it is a part of the core language itself. And there are lots of features for Kotlin that tie into the story, like the whole story about trailing lambda syntax. It's there because with trailing lambdas, you can declare your own functions that look like big language constructs on the use side. And this ability to declare your own stuff that looks like built into language is very important part of keeping Kotlin a DSL-friendly language that is extensible. It allows Kotlin to fit into a lot of different domains. and fit naturally. So whatever your domain is, you can define your own domain-specific functions so that language starts to feel as if it was custom tailored for you. So the same story with bit operators. I mean, would be just wrong to. There's also a question about consistency. Like features has to be consistent and orthogonal between each other, because all the arithmetics on numbers in Kotlin is overloadable. It would be utterly inconsistent and out of style to have like bitwise operators for integers that are available just for integers. If they are added to Kotlin, they'll definitely have to be overloadable. But this philosophy of comes with challenges. Now, we know if we make overloadable bitwise operators, people will start to abuse them. So we'll have to balance this feature then with potential abuse, or maybe invent some abuse preventing mechanism, and that's kind of complicates designer side, but that's intentional. We kind of put when we design feature for language, we put a high bar of the quality of the result we want to get and how extensible and clean it fits. And of course, because we put this high bar, sometimes it means we'll have to do extra work during design.
Thank you. We have some specific questions about different features that were out of the list, but I would suggest, because we are now out of time, I would suggest to make it a day right now and to finish this webinar. I suppose that everyone is tired already with all this. So I would suggest to provide, because we are going to finalize the results of the survey very soon. So we intentionally didn't want to finalize them before this webinar. So in order to give you ability to vote more and to have some extra time. So when we finalize, we'll try to probably add some comments about the state of other features that were on the agenda. I don't know if Roma, you want to comment right now any of the questions from the chat or we just. So I think we can just add these comments when we publish the results of the survey with some additional features, like what was also on the list. And again, if you find something important for you that you miss, go vote, comment on the issue. Surprisingly, we take into consideration your votes. It's really kind of was one of the characteristics how these features were chosen. So we really look into how many votes each feature request have, and also read carefully your provided examples and use cases. So please do all this, or I would rather say please continue doing all this. That's all very helpful to us.
Well, we also apply common sense. I mean, somebody asked what if like votes. I mean, we do apply common sense to features. I mean, votes are not the only thing that comes into consideration.
Yes, of course, then there will be extensive design and not all the suggestions are implemented, but still they are very helpful and useful. So I think on this at this point, thank you very much for joining. I really appreciate, especially in this summertime, that you decided to join our future features webinar and do some Kotlin. We're really grateful to you. If you have some remaining questions, I generally think you know where to find us. So stay in touch. Thank you all. Thank you a lot for joining today.
Thank you,
Roma, for providing these detailed explanations.
Thank you. Have a nice Kotlin, everybody. See you.